All right, so today we are going to be learning about the fundamental counting principle, and I'm actually going to save permutations for tomorrow. So today we'll just be dealing with the counting principle. So what the fundamental counting principle says is that the total possible outcomes of multiple events is the possible outcomes for each of the events multiplied together. So for example, if I'm framing a picture and there are 12 different styles of frames, and each frame comes in 5 colors, how many different frames are there at that point, right? There's 60 frames, right? 12 times 5. But then I also want to use some blue mat board, which comes in 3 different shades of blue. So now I can take each of those 60 frames and match them up with 3 different blue mats, right? And so if you just multiply them all together, you get all the possible ways that you could frame your picture, and it would be 180 ways. So I hope you're not indecisive, because it might take you a while to decide which one you want. All right, really straightforward, right? Okay. Any questions on what I did? All right, so if you had a problem like this, where a store has 3 kinds of bicycles in 3 wheel sizes and 4 colors, how many bike choices are there? Yeah, 36. You guys don't even really need to take the time to do that on your whiteboards. Right, so you just do 3 times 3 times 4. Okay, so sometimes you're going to have situations where things can be repeated and other times when they can't. So we're going to talk about using the counting principle with or without repetition. All right, so here in California, our license plates have 1 digit followed by 3 letters and then 3 digits after that. So we're going to figure out how many different license plates they could actually make if we can repeat letters and digits. So in other words, it's okay to have it be 1, AAA, 111, right? We're okay with repeating them. So I've got my letter, I've got my digit, 3 letters, and then 3 digits. So, how many possible digits are there that we could use on that license plate? How many digits do you have on your hands? 10. Don't forget to count. They're called digits also. Your fingers are also called digits. Okay, so don't forget to count 0. 0 is a digit. So you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are actually 10 digits, okay? So wherever my numbers are, I've got 10 possibilities on my license plate, right? And then how many letters are in the alphabet?
26.
Yes, 26. So all you have to do to find out how many license plates, different license plates we could make, is multiply them together. So in a calculator, multiply those. All right, anybody figure out what that adds up or multiplies to? A big number. What is that big number? 175,760,000. That's a lot of license plates, isn't it? Okay. All right. Well, suppose for some reason they decided they didn't want to have anything repeat. They wanted to have every single item on the license plate be something different. No repeated letters, no repeated numbers. Well, then what happens is, okay, so we still have our 10 possibilities. Well, we have our digit, our letters, our digits. So when we're first starting out, we have 10 possibilities for our numbers, right? But now I've used one of them up, haven't I? So how many numbers are left? Only 9. Now I've used another one up. How many are left? 8. Now I used another one. How many are left? 7. Okay? And then for my letters, when I first start out, I haven't used any. I've got 26 to choose from. But now I used one, so how many are left? 25. And then 24. So now you multiply those together and you find out how many combinations you can make without any repetitions. So multiply that in your calculator. What's it going to be? 78,624,000. Yeah. Okay. So any questions about the repetition versus without repetition? Okay. All right then. Let's have you guys figure one out here. 5 students can receive 5 different scholarships. How many ways could the scholarships be divided? So what I'm saying is I got 5 kids and there are 5 different scholarships and each of them can get 5 scholarships. These aren't necessarily like a one-shot deal. They could each receive up to 5. They could get 1, they could get 2, they could get 3. Okay? So how many ways would I be able to distribute those scholarships? So this first student, he could get 1, he could get 2, he could get 3, right? He could get 4, he could get 5, right? So how many possibilities are there for that first student? 5. The next kid, he could get 1, he could get 2, he could get 3, he could get 4, he could get 5. How many possibilities does he have? How many possibilities do each of them have? 5. So that's just 3,125 different ways it could be distributed. Okay? All right, now suppose that I've decided that each student can only win 1 scholarship. I've got 5 different scholarships, but each of them can only win 1. How many ways could I distribute it then? How many ways? All right, so yes, the first guy has 5, and then once I've used 1 up, now there's only 4 left, and then there's only 3 left, and then there's only 2 left, and then there's only 1 left. So when you multiply those together, I think you guys all said it, what is it? 120 ways, okay? All right, so when we multiply numbers like that, counting down, there's a way to actually kind of shorten how we write it, and it's called a factorial. So what I did there, that 5 times 4 times 3 times 2 times 1, that's just 5 factorial. And of course it equals 120. We just found that out. 1 factorial is just 1. And 0 factorial is also 1. It's defined that way, and it has to do with permutations and combinations. But I'm not going to worry about explaining the definition of that right now. Just know that if you see a 0 factorial, it actually equals 1. Okay? Basically, it's kind of like if there were 0 scholarships available, there's only one way that you would distribute them. Nobody gets them. So that's why it's 0 factorial is 1. All right, so just some real quick examples. 4 factorial, that means I'm just taking 4 times 3 times 2 times 1, and that equals 24. Sometimes you might see them written as an expression. So if I've got 7 factorial over 4 factorial, that means on top I've got 7, 6, 5, 4, 3, 2, 1. On the bottom I've got 4, 3, 2, 1. So do I need to multiply all those out? No, I can cancel out the ones that are the same. So really all you have to put in your calculator now is 7 times 6 times 5, which is
38.
a bigger number than that. We're multiplying.
210.
Yes, 210. Okay, and then one more. You still use the order of operations, so if you have something in parentheses, simplify what's in the parentheses first. So 7 minus 4 is 3. So really what that is 3 factorial times 5 factorial. And so that's 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And we've actually already figured those two out, haven't we? That was 6, and this was 120, wasn't it? So that's 720. Okay, pretty straightforward. Want to do some of those now for yourself? Just make sure you guys for sure understand it. There is one for you guys to do on your own. 7 factorial, tell me what that equals. All right, so what did you guys all get for that? 5,040. Okay, how about this one? Okay, so yeah, the 4, 3, 2, 1 cancel out, and we ended up with 15,120. All right, one more, and then you guys will have the rest of the time to work on your homework. All right, so what are you guys all getting? 17,280, right, okay. All right, so any questions about what we've done today? All right, so are exclamations in math going to freak you out anymore? They're really easy. It's not a big deal. Nothing to freak out about. Okay, that's it for today.